Imagine waking up tomorrow and deciding not to eat anything. No breakfast, no lunch, no dinner, just water. What would actually happen to your body? Would you immediately start burning fat? Would your muscles disappear? Would your brain stop working? Or would your body unlock a survival system that's been built into humans for thousands of years? Over the next 72 hours, your body goes through one of the most remarkable transformations it can experience. Every organ, every hormone, and nearly every cell changes the way it works to keep you alive. Here's exactly what happens, hour by hour. During the first few hours after your last meal, nothing dramatic happens. Your body is still digesting the food you've already eaten. The carbohydrates from that meal are broken down into glucose, which becomes your body's main source of energy. Insulin rises, helping move glucose from your bloodstream into your cells, while any extra sugar is stored as glycogen inside your liver and muscles for later use. At this stage, your body has no idea you're planning to fast. It simply continues operating as normal. As 6, 8, and then 12 hours pass, your blood sugar slowly begins to fall. In response, insulin levels decrease, signaling that it's time to start using stored energy instead of incoming food. Your liver begins breaking down glycogen, releasing glucose back into the bloodstream to keep your brain and organs functioning. This reserve is surprisingly limited. Most people only have enough glycogen to last about 24 hours without eating. This is also when hunger usually becomes much stronger. But hunger doesn't keep increasing forever. It comes in waves, triggered by a hormone called ghrelin, which rises around the times you're used to eating. If you ignore those hunger signals, they often fade away within an hour, surprising many people who expected hunger to become unbearable. By the end of the first day, your glycogen stores are running low. Now your body faces an important challenge. It still needs energy, but the stored carbohydrates are almost gone. That's when it begins switching to a completely different fuel source, body fat. Fat cells start releasing fatty acids into your bloodstream. Many tissues, including your muscles, begin using these fats directly for energy. But your brain has a problem. Fat cannot easily cross the blood-brain barrier, meaning your brain still needs another source of fuel. To solve this, your liver converts fatty acids into molecules called ketones. These ketones can cross into the brain and provide an alternative source of energy. This marks the beginning of ketosis, one of the defining features of prolonged fasting. As you move into the second day, ketone production increases dramatically. More and more of your brain's energy now comes from ketones instead of glucose. Many people report feeling surprisingly alert or mentally clear during this stage, although others may experience fatigue as their bodies adapt to the new fuel source. At the same time, several important hormones begin to shift. Insulin remains very low, allowing your body to continue accessing stored fat. Glucagon rises, encouraging the release of stored energy. Growth hormone also increases significantly. Despite its name, this doesn't mean you'll suddenly build muscle while fasting. Instead, it helps protect muscle tissue and encourages your body to rely more heavily on fat for fuel. By the third day, your metabolism has changed dramatically. Fat has become your body's primary source of energy, and ketone levels continue to rise. Your brain now obtains a significant portion of its energy from ketones, reducing its dependence on glucose. Inside your cells, another fascinating process becomes more active. It's called autophagy, which literally means self-eating. Think of it as your body's recycling system. Old, damaged, or dysfunctional cellular components are broken down and reused to create new building blocks. Scientists believe this process plays an important role in maintaining healthy cells, although exactly how much fasting is required to maximize autophagy in humans is still being actively researched. Physically, people experience this stage very differently. Some report increased mental focus and stable energy, while others experience headaches, dizziness, irritability, weakness, or difficulty concentrating. These symptoms can be influenced by hydration, electrolyte levels, previous eating habits, and individual health conditions. By the end of 72 hours, your body is operating in a completely different metabolic state than it was 3 days earlier. You've shifted from relying almost entirely on incoming food to surviving primarily on stored body fat and ketones. It's an extraordinary demonstration of human biology and one of the reasons our ancestors were able to survive periods without food. However, that doesn't mean a 3-day water fast is safe or appropriate for everyone. People with diabetes, eating disorders, certain chronic illnesses, those who are pregnant or breastfeeding, or anyone taking medications that affect blood sugar should not attempt prolonged fasting without medical supervision. Even healthy individuals can experience dehydration, electrolyte imbalances, low blood pressure, or other complications if fasting is done improperly. Your body was built to survive temporary periods without food, but surviving and thriving are not the same thing. While fasting activates remarkable biological adaptations, it isn't a magic solution, and the scientific evidence for its long-term health benefits is still evolving. The next time you skip a meal, remember that beneath the surface, your body is carrying out one of the most sophisticated survival programs evolution has ever created. And that's the end of today's video. If you enjoyed it and learned something new, don't forget to leave a like, subscribe to the channel, and turn on notifications so you never miss our next video. Thanks for watching, and I'll see you in the next one.